So the graph that characterizes a quadratic relation is a curve called a parabola. The parabola of the quadratic relation is expressed in the form y equals ax squared plus bx plus c. And you'll notice the difference between the quadratic relation equation and a linear relation equation is that the quadratic relation has an x squared term. So note that x squared term. So that's a way that we can tell from the equation whether we have a quadratic relation or a linear relation. So a quadratic relation has an x squared, a linear relation does not. So the parabolic curve is very common in sports, in engineering, and truly in everyday life. So here are some examples of parabolic curves. So we can see a fan or a heater. We have an arch. We have the light shining from a flashlight. We have the path of a ball, any type of ball, basketball, football. We have a satellite dish. We have bridges. And you might be able to think of some other parabolic curves as well, like, for example, a half pipe when you are snowboarding or skateboarding. You might think of the path of a basketball as you're shooting in a basketball. And you might be able to think of some other parabolic curves that you've seen as well. So try to take some time to think about where you might have seen some other curves. So now we're going to think about, how do we draw this curve? What does this curve look like exactly? So we're going to start with the simplest quadratic equation, which is y equals x squared. And to draw a parabola using a table of values that we're going to do, we're going to find about 6 or 7 points so that we create a ghostly outline. Because you'll notice something that happens when we have a curve, right? So it looks like either an upside down ghost or a U or a horseshoe or, a ghost as well in this way. So think about that when you're drawing. And then you're going to connect those using a smooth curve rather than a straight line. So let's come up with some values for x. So let's go with, start with -3, and we'll go to +3. So how do we find, if these are our x values that we've chosen, how do we find the y value? Well, our equation says that we want to take the x value and we want to square it. So the y value will be -3 squared, which is 9. And that creates a point of -3, 9. Then we're going to do the same thing for this entire chart. So we're going to start with, then go to -2 squared, which is 4. And then -1 squared, which is 1. And 0 squared, which is 0. Then we'll go to 1 squared, which is 1. 2 squared, which is 4. And 3 squared, which is 9. So you might notice a pattern happening with these y values, right? So that's important to recognize as well. So I'm just going to go ahead and fill in our coordinates. So what do you notice about your y values? Well, we notice that they start large and they get smaller, and when it reaches to a certain point, the numbers start repeating again. So what happens when we draw that? So when we plot those points, so -3 and 9, -2 and 4, -1 and 1, 0 and 0, 1 and 1, 2 and 4, and 3 and 9. Well, it creates that nice curve shape. And we're going to talk in some future lessons about why that works. Okay? So that's a pretty cool way to just graph it. So we can see how it's going to create that nice curve shape. So that's the simplest version of a quadratic relation. So what happens when the equation gets a little bit trickier? So for the next example, we're going to stick with our same x values, but our equation changes from y equals x squared to y equals negative x squared plus 8. So we're still going to take our x value and we're going to substitute it into our equation and solve for our y. So for this one, it'll be negative and then -3 squared plus 8, which gives us -3 squared is 9, but we have a negative in front of that, so -9 plus 8, which is -1. So that gives us a coordinate of -3, -1. We're going to do the same thing all the way down our chart. So we're going to do -2 squared plus 8, which works out to be -4 plus 8, which is 4. Then we're going to go to -1 squared plus 8, which is -1 plus 8, which is 7. Then we're going to go to 0. So we have -0 squared plus 8, which is 0, plus 8, which is 8. And we're going to work our way all the way down the chart. So -1 squared plus 8 is -1 plus 8, which is 7. Then we have -2 squared. So again, hopefully you're realizing that there is a pattern here. Starting to happen. All right, so here we go again. So again, we've noticed a pattern that happens in our chart, right, with our y. So they started small, they got larger to a certain point, and then the numbers started to repeat themselves. So that's always going to be a pattern that you'll see when you have a quadratic relation. So let's go ahead and plot these points. So -3 and -1, -2 and 4, -1 and 7, 0 and 8. Then we have 1 and 7, 2 and 4, and 3 and -1. So you'll notice that this time our quadratic relation opens down, so it looks more like a ghost than the other one. And it doesn't start at the origin. Okay, so things to explore and to figure out. All right, let's do another example and then we'll summarize what we found. So here's another example. We have y equals x squared minus 2x minus 8, and we want to draw the points from negative 3 to 5, so a little bit more than what we did before. So I'm going to start by writing my x values. So negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, and 5. Then I'm going to do my y values, and this is where I'm going to do some calculations. So I have negative 3 squared minus 2 times negative 3 minus 8. That gives me 9 plus 6 minus 8. 9 plus 6 is 15, and 15 minus 8 is 7. Then I move on to the next one. Substitute in my value for x, which is negative 2 this time. Negative 2 squared is 4, plus 4, negative 2 times negative 2, and then minus 8. 4 plus 4 is 8. Take away 8 is 0. And then I'm going to go on to the next one. Plug in my value for my x, which is negative 1 this time. And I'm going to solve using BEDMAS. So negative 1 squared is 1. Negative 2 times negative 1 is positive 2, minus 8. 1 plus 2 is 3, and 3 take away 8 is negative 5. Keep going. All right, so we had our 0 one, which was easier for us to solve. Then we go to 1. So 1 squared minus 2 times 1 minus 8. So 1 minus 2 is minus 1, and minus 1 minus 8 is negative 9. Let's keep going. So substituting in 2 now for our x. 2 squared is 4. Minus 2 times 2 is minus 4 is minus 8. So 4 minus 4 is 0, and 0 minus 8 is minus 8. So already we can see that, hey, look, we've reached that point where it's going to start repeating itself. So hopefully when I do my 3, I'm going to get a value of negative 5. So 3 squared is 9, minus 2 times 3 is negative 6, minus 8. So 9 minus 6 is minus 3. 9 minus 6 is 3, and 3 minus 8 is negative 5. So look at that. So we can hopefully, again, see that we can have this pattern where the numbers start to repeat themselves. All right, so let's go ahead and plot those points. So we have negative 3 and 7, negative 2 and 0, negative 1 and negative 5, 0 and negative 8, 1 and negative 9, 2 negative 8, 3 and negative 5. We have 4 and 0, and we have 5 and 7. So there we have this nice parabolic curve. We're going to do our best to connect these using a nice curved line. And there we have our parabola. So what did we discover? Well, some initial observations. So we're going to study some parabolas where our a value is 1 in this case. So some initial observations about quadratic equations when it's y equals x squared plus bx plus c. So we have no number in front of our x squared except for maybe a negative sign. So what happened when we had that negative sign in front of the x squared term? So what did it do to the graph? Well, if we take a look back, our x squared one, we say that this opens up, so it creates a U shape. But the x squared, the negative x squared one, it opened down. So the negative sign, it causes our parabola to have a reflection about the x-axis, or we can say that it opens up versus opens down. So x squared, we say, opens up. So it creates that U shape, and a negative x squared opens down. So it creates more of that ghost shape. Okay. So what happens when there's a coefficient in front of the x term? So we'll notice that this last one here, we had a negative 2x. So this was the only one that had an x term in the equation. And what happened to this equation? Right? So what did it do? Well, it moved our equation, didn't it? Right? So it moved our equation from a normal point, right, which we would have seen, and it moved it left or right. So instead of starting at this origin, at 0, 0, it moved it left and right. And you'll explore more about transformations of parabolas in grade 11. So this is just a quick intro to that. And then what happens when the equation has a constant term? So if we take a look back at our equation here, where we had negative x squared plus 8, if our equation was just a negative x squared, it would have a vertex that was at the origin. But this one, it moved it up, right? So anytime we have a value of c, then it either moves it up or down depending on the sign. So these are just some quick happenings about parabola and how it can move or transform based on the original equation. If you have any questions about this lesson, please reach out to me, send me an email, sign up for a virtual help session, and I will see you in the next lesson.